So in this video, I'm going to be evaluating the limit as x approaches negative pi over 2 for the function f of x, which is going to be sine x squared. So this is f of x. So I'm going to be evaluating this limit using a graph, and you'll see that this is really easy to evaluate a limit using a graph. So in order to graph this function f of x, I'm going to be using Desmos. So desmos.com. This is a free graphing calculator website that you can use to graph any function. It'll immediately graph it for you, so it's really good. So let's now scroll down a little bit. You might have seen that white part. This is actually a screenshot of a Desmos graph. And this is the graph of f of x, which is sine x squared. So in order to evaluate this limit, what I'm going to do is I'm going to look at the output values as x approaches negative pi over 2 from the left and from the right. As you will see, the f of x values, as x approaches negative pi over 2 from the left and from the right, those f of x values approach this single point, which is positive 1. And actually, that is your limit. So if we look at the one-sided limits, essentially, as we look at the x values as they approach negative pi over 2 from the left and from the right, we see that they approach a single point, and that single point is when f of x equals 1, and that is your limit. So if I go back up, this limit problem, the answer to this is just 1. And you might be making a connection from the previous video in where we made a table. So we actually made a table in where we would look at different x values as they approach, from one side, say from the left side, and also from the right side, and we'd look at what x values are approaching. And in this case, we made a table. We look at from the left side they approach 1, and from the right side they approach 1, as the x values get closer to negative pi over 2 from the left and from the right. So it's the exact same thing, except we don't have to evaluate the actual output values for different x values, which takes time. So this is a easier method. But as I said, or I didn't say, sometimes the limit is not going to be a whole number. It's not going to be this beautiful number like this, like 1. It could be like a non-terminating decimal or some sort of messy number. And in that case, this method is not the best method to use. So let's actually make some alterations to this graph, and just to play around a little bit, since this video wouldn't be too interesting if I just explain this. So let's say that we had a removable discontinuity at this point, at negative pi over 2, and let's say that the actual function value is at 0.5 for this right here. So at negative pi over 2, the actual function value exists at 0.5. So we have this kind of this removable discontinuity at that point. So now what would the limit be? Well, you probably can guess that the limit is still going to stay the same. So as I look at the x values as they approach negative pi over 2 from the left, and as they approach negative pi over 2 from the right, they are still approaching that 1. They're still getting closer to 1. Even though the function does not exist at that point, we still have the limit of 1. So that's also something important. And so just to put it like as a general rule, we can put it up here. The limit, right? And I'm going to put this in green just because. So the limit as x approaches a number, we'll call this n, I don't know, we can call it whatever we want, for the function f of x, if this is not equal to the f of x value, right, the actual fx value, we know that we have a discontinuity. I don't know how to spell this, discontinuity. So this is kind of a general rule of thumb. So if you see this on a question or something where the limit as x approaches a value for the function is if it's not equal to the actual function value itself, then we have a discontinuity. And we saw that in this example right here when we had a removable discontinuity right over there. The limit stays the same, but we know that this function is not continuous at every point it's discontinuous at x equals negative pi over 2. So I hope you found this video helpful. It covered different things, but overall this video was just to help you understand limits graphically.